Okay, so I know I said I was going to talk about the noise in this video, but let's actually talk about the filters first, because they're going to be more fun to use with the noise later on. So, and with noise module, I'm talking about this very little guy in the middle here, noise source, and we have white and pink. But first we're going to take a look at the filter. So we already looked a little bit into this main filter. Let's finish our discussion with that. I have no idea why my sound cleared. I'm going to go with my init preset, which sends a saw to this filter. Now, the filter, what it does, it will cut away the high frequencies, and we've heard that a lot already. This is a low pass filter, so it will pass the low frequencies and it will cut the high frequencies. There are two other controls that we haven't talked about. The first is frequency range, and these are three different ranges in which the filter can operate. The first one has a very small range, and you can hear that if I use that, even if the filter cutoff is all the way up, it still sounds a little bit dull. The second frequency range goes up to 20,000 Hertz, so it actually makes the sound a lot brighter. And the third one has a range to, I believe it's all up into the 80,000 Hertz, like a super wide range. So with this one you can hear that towards the end of the filter it's already very bright in that sort of whole area between 2 and 6. So frequency range is just think of them as different color selectors. And then there's one other knob here, which is regeneration. Now this is usually called resonance, but I actually like the name regeneration a lot better, because this is actually what happens with normal resonance in all filters. Resonance basically is sending the signal back into the input of the filter. So the signal output in this guy, the blue cable, internally there's another output, and that goes back into the signal input on the left side there. And the resonance, it sets the level of loopback. And if you do that, if you take the output after it's being filtered and you send it back into the filter, that means that that you're going to get a more pronounced sound at the cutoff frequency. So it's going to boost the point that you set with your fixed control voltage here. And I accidentally removed my input there. So let's take an output. And that's resonance, and you can get like super funky talking kind of sounds with that. It's a classic effect. So let's try and use the auxiliary output to control the filter cutoff using resonance. And then let's go with a saw down type. And you'll hear that after a certain point, if you set the resonance very high, you're going to get a new tone. And we call that filter feedback, and with that you can actually completely make melodies just with the effect of the filter. So let's try one pretty cool thing. Let's try taking one of the noise outputs and sending it to the input of the filter. So right now we're only hearing noise. It doesn't have any musical tone. And then let's remove the control input there. So we just get basic noise, and then let's set the pitch of our keyboard to control the filter cutoff. So now the notes that I play decide my filter cutoff. And then I can actually play different notes. So let's try that with no sustain and make sort of a plucky type of sound. So that is a classic filter cutoff. Let's try third range. have a little bit more control over this. If like the signal itself doesn't have a noise like level, so we can send it through one of the attenuators. And now we can control the level of noise going into the filter, and with just a little bit of noise that's already enough to trigger the filter, and then what you're hearing is just filter feedback. So in this case we're not using any oscillators. It looks like we're using this guy, but we're not. So we call that a self-oscillating or feedbacking filter, and it's a really cool thing. This is the main, like, very colorful, cool filter that we have here. Let's take a look at the fixed filter bank, which is on the left side here. It's this sort of big filter. We can think of this more as an EQ with an extra low pass and an extra high pass on the left side. We cannot control any of these knobs using a control input like we have with this fixed control filter, but we can MIDI learn all of them. Let's first just see what it sounds like. So I'm gonna remove some of the things here. Let's see, and then let's use just a sawtooth for now, and let's send that into the input of the fixed filter bank, right? So we have our pretty much our initialized patch. We send the saw to the mixer, and the mixer sends to the input of the fixed filter bank. We're going to send the output of that to the input of the regular filter, and then the output of that is going to our amplifier. So right now, when I press any notes on my keyboard, which I'm doing right now, as you can see, I'm not hearing anything, and that's because these are levels that we set here. So if we don't set the levels of any of the bands, we're not gonna hear anything. So you can hear that you can get a lot of different sort of almost vocal-like sounds out of that. It does make the signal a lot quieter, so that's why I'm boosting the master gain here. I like sort of that point there, the sort of resonancy sound. Let's try making a pad out of this. So we go into polyphonic mode so that we can play chords. Okay, so that's pretty, right? And then we can mess around with these a little bit more. And this one will get a lot more fun when we get into MIDI learning these controls, because so far this is pretty much all we can do, because we cannot control any of the controls or knobs on here. So we're going to do that later using MIDI learn. But that's the fixed filter bank. It's a very famous sort of Moog creation. Right, there's actually two more filters which are right in the middle here, and we have a low pass and a high pass, and these are also not controllable, but the cool thing is that we have two of them, and what that means is that we can set them up in serial or in parallel. So let's try something cool. Let's actually try to make our first drum sound, and for drums noise is a great source. So let's see, let's take a white noise output and send that into the signal input of this. Actually, let's send that into the filter input of one of these filters. So white output to the input of this low pass filter, and then we set the output of that to the input of this high pass filter, and then we send that to the regular filter. Alright, so let's first hear what that sounds like. So far nothing. Okay, so now we've created a nice sort of noise sweep. We can also make waves. And we can use the two different filters. Because they're routed in serial, it means that it first goes through the low pass and then to the high pass. So we can actually make a bandpass filter using this, where we only allow a very small range of noise through. So now we're getting a very narrow band of noise, and let's use that instead of a signal input as a control input, and then we'll send a regular sawtooth, or actually let's go with the sine. We'll send the sine wave into the filter. So now we're filtering our modulation signal, which is one of those cool things that you can do with modular synthesis. And then we're going to do the same thing where we patch or pitch to the filter cutoff and we give it a very high resonance. And now we really get to play around with this noise, because the noise is sort of that high sizzle you hear on the sound. And we can shape that using the two filters. I know I said we were going to do drums though, so let's actually go into drums. So for drums, and the way you would use noise is you would send it through some sort of amplifiers that we have control over the level. So let's take the output of that noise, which is this green cable, and route it into one of the attenuators. Actually, let's go with the reversible attenuators. So we take the output of that high pass filter and send it into the input here, and then we set the output of that to our filter. And then we remove the control there for a second. Alright, and then of course we need to set our level. Okay, so that, like, we could consider that to be a drum hit. We just want it to be controlled by something. So let's take the auxiliary output and let's use a saw wave to control this attenuator. Okay, so now we're getting some sort of drum sounds. Let's use the filters to shape it a little bit more. So if I use a high pass filter, I can make hi-hat like sounds. But with a little bit of reverb or delay and more of a low pass filter, we can sometimes almost make tom like sounds. And let's give it a full sustain here. Okay, and then let's use another signal to control. Let's see, we haven't used this regular oscillator here. I'm going to try to use a sawtooth and send that into the control input of this second filter. And actually, while we're at it, let's set that up through an attenuator as well, like that. So now we're using that sawtooth to control this filter, and we're using this auxiliary to control the attenuator control amount. And let's actually use an reversible, inversible for this as well. Okay, I like that. It's starting. It's more of a difficult sound, but it's starting to get into the area where I like it. I would just like it to be a little bit louder, and not necessarily louder as in louder, but more as in more saturated. So to do that, what I'm going to do is I'm going to take the output of this VCA and I'm going to send it into one of the amplifiers that we have. Specifically, I want to send it to the input. Like that. So these amplifiers here, they are like an extra stage of amplification, and they can really give like a nice sort of saturation to the signal. Okay, so now one last thing I want to do is let's actually use the ribbon control for this. This would be a great example of using the ribbon control. So let's set the trigger of the ribbon to let's set the trigger of the ribbon to our envelope trigger, so that if we touch right there somewhere on the ribbon, it's going to trigger the envelope. And then let's set the ribbon main, or in other words the pitch, to the frequency input here, so that we can change the rate of these drums. Let's give it a little bit of a bigger range there as well. And actually let's set that ribbon main to, let's set the pitch control here to the pitch input as well. Okay, and as of right now, we actually want to control this pitch. There we go. Okay, so I was pitch controlling the wrong oscillator, because we're using this one, the middle one, as our modulation source. So right now what we did is we set the ribbon main, which is going to be the pitch. We set that to control the frequency input here of this 921 oscillator, and that one, we're using that one, the auxiliary out of that, to control this reversible attenuator, which in turn this is basically our amplifier right now for the noise signal. And after that, the noise goes into the main signal. So now, using the frequency on the ribbon controller, we can sort of change the rhythm of our, not really drums, but something close to that. And then we had that 1-2 switch in which we could switch the range. So if you set it to 2, it has quite a small range. That was a sweep all the way from left to right. And if you set it to 1, you have a big range. Since we're messing with the ribbon, we might as well set the ribbon aux to control this filter, so that we can use this slider here on the left to control the actual filter cutoff. So I like that kind of stuff. I don't often make drum sounds, so it takes a little bit longer. But that is sort of the starting point of creating percussive like sounds, right? So I think we have a couple of things to do still. We looked. Let's get an overview. Okay, so we looked at the fixed filter bank. We looked at the attenuators, all the filters, the VCAs and their control inputs, the envelopes, all the different things about the oscillators. I think what's left is the effects and the noise, but actually the noise is pretty extensively covered right now. The only thing I didn't explain yet is that we have pink noise, and so far we've been using white noise, which is the brightest type of noise. We could just as well use pink noise, which actually generally is a little bit better for drum-like sounds. So instead of this white output, we take that pink output. You can hear it has more low end and more warmth to it, even though it's being processed quite a lot right now. So that's basically all there's to say about the noise sources. They have two outputs. That's pretty much it. So yeah, so let's still talk about the effects, and then we're going to get into, and the effects are just the delay, and then we're going to get into the actual audio MIDI bridges and some of the audio sharing options, which should be really fun. We're also going to take a look at MIDI learning.